Okay, in this section, we're again going to just combine two of our previous lessons. We're going to graph some absolute value inequalities. So we're going to combine the lesson that we just did about how to graph absolute value equations, and we're going to go back and remind you, okay, with inequalities, we're just going to shade either above or we're going to shade below. So we're going to create the table of values just like we just did in the last lesson. We're going to graph. A reminder that we're going to use a dotted or a dashed line for these symbols, and we're going to use a solid line for these symbols. We're going to shade above for these symbols, and we're going to shade above the graph for these symbols. Okay, here we go. So our first one, again, to find that vertex, we're going to set the stuff on the inside equal to 0. That's going to give us x is -1, and that's going to be the middle portion of my V-shaped graph. Again, we're going to actually graph before we start shading anything. We're going to focus on the graph y equals the absolute value of x plus 1. And we're going to plug in those values. When I plug in -1, I get 0. That, again, will be my vertex. Then I'm just going to pick values on each side. I'm going to pick 0, 1, and 2 on that side, and -2, -3, and -4. And you should see that symmetry. Plug those values in, and here's what you're going to get. And then you're just going to plot those values. Here are those dots, -1, 0, 0, 1, and 1, 2, and 2, 3. And then for the other side, again, you can just use your symmetry to copy those points. And again, that was all old material. Now you could use slope, and you can find some more points on this graph. Rise 1, run 1, rise 1, run 1. Now let's go back to this. For less than, we're going to do a dotted graph. So my graph is dotted and not solid. And then simply once you have it dotted or solid, once you draw that graph, we're just going to shade. Since it's less than, you're just going to shade everything, including over here, everything below that V-shaped graph. And that's going to be your graph. Next one, set the stuff inside of the absolute value equal to 0 and solve it. That would give you a 5, is where your vertex is going to be located. I put that in the middle. Once you plug in 5, we're going to subtract 5 and take the absolute value, and then subtract 2, we'll get -2. Pick some values on each side, 4, 3, 2, 6, 7, and 8. Plug those values in as well, and here's what you'll get. And then simply take and plot those points. You can use slope to actually come up with some more points. Now, there is, that's something to think about. The slope is usually the value in front of x. Is there a connection between this and linear graphs? And sure there is. So there's some more points that we can plot to complete our graph if we would like to. Since it's or equal to, we're going to do a solid graph. So I'm going to draw a solid graph here. So there's the graph of my absolute value function. And then since it's greater than, you'll simply go to any point on your graph, and that'll tell you where you're going to shade. You're going to shade above this. So your answer will be any point that's located above that graph. Number 3, let's do another one. Set the stuff inside equal to 0. Now this one's going to be one of those that has a weird line of symmetry. Subtract 6 gives you 4x is -6, divide by 4, and that's going to be actually -3 halves. When you plug in -3 halves, let's see, that's going to be -6 plus 6, you're going to get 0. So my vertex is going to be located at -1.5, which is -3 halves, 0. So there's my vertex. So, well, this one won't be quite so bad. You can pick values on each side of that, but that is going to be your where your line of symmetry is located. So I'm going to pick maybe -1, 0, and 1 on one side, and I'll pick -2, -3, and -4 on the other side. Plug those values in to find your y values, and there's what you'll get. When I plug in -1, I get 2. When I plug in 0, I get 6. And you can continue that same pattern. Plug in 1, you get 10. And go ahead and plot the rest of your points. And it'll look something like that. And you can see that same rise 4, run 1 slope as before. Since it's greater than, we're going to have a dotted line here. So it'll look something like this. There's your arrows. And since you're greater than, that means to go to any point. We're going to shade above those points that are on your graph. So you're going to shade on the inside there. Number 4, set the stuff on the inside of the absolute value equal to 0. That tells you where your vertex will be. When you plug 0 in, you got to multiply by 2. Absolute value 0 is 0. Take the opposite of it, still 0. 0 plus 3 is 3. So you're going to have a vertex on this one at 0, 3. Pick some points on each side. We can go 1, 2, and 3 on one side, -1, -2, and -3 on the other side. Let's plug those in. Now, as you plug these in, I do need to remind you that make sure multiply first, then make it positive if it's negative. So multiply first, take the absolute value, and then whatever you get, put a negative in front of it. Okay, and then you'll add 3. So let's plot these points that we got. And again, you can look at your patterns. You can see the over 1, down 2 pattern, and you could continue that pattern on if you want some more points. So there's your graph. Since it is or equal to, let's make this a solid graph. Let's put an arrow there. Solid graph as well on this side. Put an arrow there, and since it is less than, we're going to shade, go to any point on your V-shaped graph, and let's shade less than. Let's say shade below those points, so we're going to shade the inside of that region. Number 5, set the stuff on the inside, 2x minus 12 equal to 0. Move the 12 over, divide by 2, and it gives you 6. So your vertex is going to be located at, plug in 6, that's going to be 12 minus 12 is 0, absolute value is 0, 0 minus 7 is -7. So your vertex is located at 6, -7. Let's plot that point. Now let's pick some points on each side of it. We can go 5, 4, and 3 on one side, 7, 8, and 9, which is not going to quite fit on the other side. When you plug these values in, here's what you get. And then again, you just simply plot those points. Let's draw those dots. 3, -1, 4, -3, 5, -5, and you can see that pattern. And then the same pattern on the other side of your vertex continues. You can go up to and over 1, use that slope to find some other points on your graph. Connect your dots. Since it's or equal to, we are going to draw a solid line to connect them. Then we're going to come back up on the other side. Arrows. Greater than means we're going to shade above every point on your graph, which would be this direction. So we're going to shade all of that graph. Number 6. Again, 3x plus 9. Set it equal to 0. Subtract 9 divided by 3 gives you -3. When you plug that in, this will be negative. Let's say 3 times -3 is -9, plus 9 is 0, the absolute value is 0, take the opposite 0, 0 plus 4 is 4. So there's your vertex at -3, 1, 2, 3, 4. Now pick some points on each side. We can do -2, -1, and 0 on one side, -4, -5, and -6 on the other. Again, if you equally space these, there should be a pattern. Plug those values in and see what you get. And here's what I got. Let's plug those points in and make sure that it follows a pattern. Let's see, when -2, +1, -1, -2, and you can see the same slant, over 1, down 3, over 1, down 3, and again, on the other side, you have the symmetry going on, so you have points here, here, and here. You can follow the same pattern and find you a couple more points if you need them. Less than means we are going to dot this thing. So let's draw arrows. Let's dot it on the other side as well. And again, less than, so we're going to shade below every point. So take any point on your graph and draw arrows. We're going to shade in that direction. So there's going to be the shade of your graph.